thank you, Mr. Kertsopoulos, for his amazing presentation. Let us begin. So now the session is open for questions, comments from the audience.
So I understand that your constructions are all based on empirical laws based on Maxwell's equations of magnetostatics. My question is, can you also give some theoretical background, how you change the different symmetries of the multiple devices which have different points of equilibria? That is what you demonstrated today. Is there some mathematics behind also?
Of course there are mathematics behind it, and at the same time, most important at the beginning of all this, which is actually, the beginning is that the products had to be made so that we have an invention. Otherwise we cannot patent something, right? So we don't start with a theoretical part, we start with a practical part. So once we have the experiment, then all these experiments lead to the mathematics. So we are working backwards. We're not getting the theory first. Not so far. No one has prophesied this. No scientist, no author, no one has ever said that maybe sometime in the future someone might come. The first thing is we patent it. We make them as products. And then we say we have the magnetic devices, they're ready. If someone wants to have them, they can have them in their lab, at a very low cost. So what we have, everybody can have, and they can make their experiments and start making also their own mathematics as scientists. Because if I, as an inventor, give all the mathematics also behind it, what's the use? There will be no interest. So the main thing is this, is when you take my book and say, what am I going to have from this book? What am I going to learn? What you're going to learn is you're going to learn the whole technology of how to make this thing by yourself. How this thing is made. Why it is made like that. And the first thing we would like to know before we come to the equations, which will only prove again that Maxwell was correct. Okay? Now, the next thing we need is what makes this thing work. What is the difference? What has the inventor done that no one has done up to now? And this is explained in the book. And I will explain it to you in a few words, in very few words. The main thing that is done is that we are using the magnetic lines, the flux of the magnet, all right? We're using it accordingly in a distance, in every distance. We use it fully. If we put two magnets, one against the other, okay, they're like or they're unlike. So what is happening? The magnetic lines in the front of a magnet and the magnetic lines in the front of the other magnet just come across and they either attract or they repel. Now what the invention does is this. At no point one magnet is against the other. It's this. The magnets are off, okay? So look what happens. I take two magnets which are like, so we can understand the theory behind it. So we take two magnets that are, for example, alike, and we take them against each other. But they're not like this, they're like that. So at a far distance, they repel. But the beautiful thing about the magnetic lines is that they choose to connect or disconnect or repel in the fastest manner. What is the shortest distance? So in the shortest distance, if they find another magnetic line, they will interact with that line. So look what happens. They're like this and they repel. They're like, correct? Now, as they come close, okay, I have north and I have north, okay? So they repel, okay? So they do what we expect them to do. And as they come like this, look, they come close to the sides of the turn. So this north interacts with the south, interacts with the back pole of this magnet. And this magnet interacts with the back pole of this magnet, and they attract. So over here they're like, because it's the front of the poles. But when they come close to a distance, they are like and they are also unlike. They are equal. And if you push them a little bit, then they attract. They are unlike. So this is the basic theory that we should understand, is making all the different symmetries, which are many symmetries, and when there are many symmetries, things really come out because we understand many other things also about other sciences. For example, this thing here is the first macro, which is not micro. We can touch it with the hands. Experimental device, which can show us many other things where we have questions in science. When Hubble found in 1929 that the galaxies and every planet, everything is repelling, everything is going, as repulsion. And all that science knows is that gravity is never repulsive. Gravity is always attractive. So, when Einstein tried to prove what the phenomenon was, Einstein gave the equation of why we have the repulsion of the galaxies. So when the scientists looked at it, because it was a theory, they said this can never exist, so Einstein is wrong. And after 45 years, 1996, quantum physics proved that Einstein was correct. His equation is actually correct, and it's very critical. If it was a little bit less or a little bit more, the galaxies would not do this, would not repel. Now, his equation shows why, in a mathematical way, they repel, but it does not show how. It does not show how. How come an attractive field, which comes from gravity, how come it becomes repulsive? No one has an answer for this. This experimental device is not gravity, it's magnetism. So, it doesn't mean that it will tell you how. However, when in magnetism, we can have between magnetic constructions repulsion, attractive, stable balance, unstable, and we can have all these things in magnetism, then we can make parallelism to other sciences. And maybe we can help ourselves to find out the ways why in gravity a repulsive field all of a sudden can become, an attractive field can all of a sudden can become repulsive, as we have also in magnetism here. So, I don't know if I answered your question. I have myself many mathematic formulas concerning the interactions and the multiple interactions. But at the moment, I'm not concerned to publish them because I would like this to come out from the scientists themselves. I would like to give them ground for this. Thank you for your question, sir.